Real-time operating system. Explained in simple words. What does real-time operating system mean? A real-time operating system, RTOS, is a type of operating system that processes data and responds to events within a very strict time limit. It ensures that tasks are completed within a predictable and guaranteed time. In simple words, real-time operating system equals system that responds immediately. It means a real-time operating system responds to events instantly, processes tasks within strict deadlines, provides predictable response time, supports time-critical applications, ensures reliable system behavior. So, RTOS equals fast and predictable response. Example idea. Imagine a system controlling airplane navigation, medical equipment, industrial robots. If the system delays even a few milliseconds, it could cause serious problems. So the operating system must respond immediately. This is where a real-time operating system is used. Why it matters. Without a real-time operating system, cross-mark critical systems may respond too late. Cross-mark safety systems may fail. Cross-mark machines may malfunction. Cross-mark data processing may be delayed. With a real-time operating system, checkmark tasks execute within deadlines. Checkmark fast system response. Checkmark high reliability. Checkmark safe operation of critical systems. Checkmark predictable system behavior. Real-life examples of real-time systems. Real-time operating systems are used in air traffic control systems, medical monitoring devices, industrial automation, robotics systems, automotive control systems, space and defense systems. These applications require immediate responses. How a real-time operating system works. Step by step. Event occurs. Sensor input or signal. Down pointing arrow. Operating system receives the event. Down pointing arrow. High priority task is scheduled immediately. Down pointing arrow. CPU processes the task. Down pointing arrow. System responds within strict deadline. Flow. Event means immediate processing means quick response. Features of a real-time operating system. A real-time operating system provides deterministic behavior, supports priority-based scheduling, responds quickly to events, handles time-critical tasks, ensures minimal delay. It focuses on guaranteed timing. Types of real-time operating systems. Hard real-time system. Deadlines must never be missed. Examples. Aircraft control systems. Medical life support systems. Soft real-time system. Occasional deadline misses are acceptable. Examples. Multimedia systems. Online video streaming. Tasks handled by real-time operating systems. Real-time operating systems handle sensor monitoring, device control, industrial automation, real-time data processing, robotics control, safety monitoring systems. Advantages of real-time operating system. Checkmark very fast response time. Checkmark high reliability. Checkmark predictable system performance. Checkmark efficient task scheduling. Checkmark suitable for critical applications. Disadvantages of real-time operating system. Crossmark complex system design. Crossmark expensive development. Crossmark limited flexibility. Crossmark requires specialized hardware. Crossmark difficult debugging. Comparison with other operating systems. Batch operating system. Processes jobs in batches. Time-sharing operating system. Multiple users share CPU time. Distributed operating system. Multiple computers work together. Real-time operating system. Responds within strict deadlines. So, RTOS equals time-critical computing. Common beginner mistakes. Beginners often think real-time means very fast only. Ignore the concept of deadlines. Confuse RTOS with normal operating systems. Assume all systems require RTOS. These happen because real-time systems focus on predictable timing, not just speed. Good practices. Conceptually. Checkmark use priority-based scheduling. Checkmark minimize system delays. Checkmark monitor timing constraints. Checkmark use reliable hardware. Checkmark test real-time performance carefully. Real-life analogy. Real-time operating system is like an emergency response system ambulance. When an emergency call arrives, the response must be immediate. Delays are unacceptable. So, RTOS equals instant response system. Important point. A real-time operating system responds within strict deadlines, handles time-critical tasks, ensures predictable system behavior, supports safety-critical systems, provides fast event processing. Without RTOS, crossmark delays may occur. Crossmark critical systems may fail. Crossmark safety risks increase. Simple definition. Real-time operating system equals an operating system designed to process tasks and respond to events within a guaranteed time limit. Final summary. Real-time operating system. Checkmark processes time-critical tasks. Checkmark responds immediately to events. Checkmark ensures predictable timing. Checkmark supports critical systems. Checkmark provides reliable performance. Without RTOS, crossmark delayed responses. Crossmark unpredictable system behavior. Crossmark unsafe critical systems. With RTOS, checkmark immediate task processing. Checkmark reliable system performance. Checkmark safe operation of machines. Checkmark accurate timing control. Checkmark efficient real-time applications.